So I've done quite a few LED projects on my channel, and I've heard from a number of you that said you'd really like to try an LED project, but you find that the things are too complicated or you don't feel like you can or don't want to solder. So today I'm going to show you an easy way to get your feet wet. We're going to build a little test controller to give you the opportunity to play around with LEDs and WLED, and we're going to do this without any soldering, and we're going to do it in only about 15 minutes. So hang around. Hi, welcome to Resin Chem Tech. Now, if you've built a WLED controller in the past, this video is probably not for you. It's really meant for those folks that I've heard from who said they'd really like to try one of these projects, but feel like everything that they see makes it seem too complicated, or they don't feel like they have the ability to solder. Now, what I'm going to cover today is by no means the only way to build an LED installation. There are a lot of different types of controllers, a lot of different LEDs, a lot of different ways to mount them. What I'm going to focus on today is building the most basic controller that I can to allow you to at least try out WLED and some LED strips. And we are going to build this thing from start to finish, step by step, in around 15 minutes. Now, why is the video longer than that? Well, I'm going to talk a little bit about the parts you're going to need, and I'll answer a few questions that I've gotten about LED controllers in general, and we will also show a little bit about WLED and its features at the end. As always, check the video description for lots of more information, including all the parts that I show, more information on LEDs and LED controllers, wiring diagrams, and more. But with all that behind us, let's get started. So this is everything we're going to need to build our test LED controller. Obviously, we're going to need some LEDs. I'm using WS2812B 5-volt LED strips. And just for the purpose of this video, I am going to mount mine in this aluminum channel just to make it a little bit easier to see and shoot on the camera. And this does come with its own diffuser, but you certainly don't need this for your test build. Now, the number of LEDs really doesn't matter for this test case, except for the fact that it will influence the size power supply we need. So for this test, I would recommend you are somewhere between 30 and 100 LEDs. That will allow us to maintain and use one of these smaller power supplies instead of the bigger transformer style. But again, 30 should be enough that you should be able to see some effects, and 100, maybe even all the way up to about 130, you're okay with one of these size power supplies. We'll come back to this in just a second. Next, we're going to need a microcontroller. In this particular case, I'm using an ESP8266 node MCU style because it does come with all the pins pre-soldered onto there, so we don't have to solder those on. I would normally use something like a D1 Mini or an ESP32 Mini, but in that case, you would have to solder pin headers on there. So for this test, we're just going to use the simple ESP8266 node MCU. I am going to go ahead and include a logic level shifter in this particular build. Now, you really don't need it in a lot of cases if you keep your controller very close to the start of your LED strip, and you definitely don't need it for this particular test case. But I do recommend that you include one of these in all of your permanent builds. And I've had a lot of questions about how to wire it, so I'm going to go ahead and include it here. If you don't have one and don't want to use one, and I should be fair that in this particular case, I did have to solder these pin headers on, but you can buy them with the pins already attached. I'm just going to show that it only adds a couple of minutes to the project, and if you're not using one, don't worry. I'm going to show how to go ahead and wire this without using the logic level shifter as well. And as I mentioned earlier, we're going to need a power supply, obviously 5 volts, but the number of amps is again going to be dependent on the number of LED pixels that we have. For the purposes of this test, and as a general rule of thumb, take the number of pixels you're going to use and multiply by 0.06. That is 60 milliamps per pixel. So for example, if you have 100 LED pixels, multiply that by times 0.06, and that gives you 6 amps, and then you just want to round up to the next bigger size. So in this case, I'm using a 5-volt 10 amp, even though I'm only going to be using 33 pixels in my test strip. It's always better to have more amps available in your power supply than to not have enough. Now, a lot of these smaller power supplies do come with this little connector. We are going to use that here. I don't recommend that you use that for anything that's going to require higher current. Instead, I recommend you use something like this barrel connector that we'll simply connect to the end of this. These aren't meant to carry high current, but for the purposes of our test, we're going to go ahead and use this. And finally, I'm just going to need some breadboard jumpers. Going to need some wire connectors. I'm using these Wago clips, which are really handy, but you can use wire nuts in place of those. I'm going to need some miscellaneous wire. I am using solid core here, and that's really just so I can insert the wire directly into the breadboard. If I was doing a soldered version, I'd be using stranded wire. I'm going to temporarily need a USB to micro USB data cable for flashing WLED onto our controller. And the only tools I'm going to need here is a wire cutter and wire stripper. Now, there is one other item that is optional, but we are going to be connecting to our LEDs through this JST connector. Now, one option is to simply cut the male end off of the end of your LED strip. But if you plan on reusing these LEDs, there may come a time when you want to daisy chain LED strips together. You may not want to cut this off of the end of your existing strip, in which case you can buy these JST connectors separately, and they're not very expensive. And then you can use this instead of cutting the end off. But for this, we're going to try to do it as quickly and as easily as possible with as few parts as possible. So I am going to cut this end off the end of my LED strip and then reuse it. So with all the parts covered, we're ready to start the build. But before we actually start assembling everything, the first thing I want to do is I want to flash WLED onto my microcontroller. And to do that, we're going to need the microcontroller and our USB cable with a computer with an internet connection. So at this point, you're going to go ahead and plug your controller, your Node MCU, into an available USB port on your computer and go to the website install.wled.me. It should bring up this site here. You do have an option to install some different versions. The latest is usually fine. You cannot install Sound Reactive version on an ESP8266, so don't try that one. But otherwise, we'll just select the latest and click Install. Now, it should bring up some COM ports, and you're looking for the one that says USB to UART bridge. If you don't see that or you're unsure which COM port it is, try unplugging your device from the USB port and see which COM port disappears and then plug it back in again. If you still don't see a COM port that looks like this, there is a link on here of what to do if no device is found. But we're going to go ahead and select this one and click Connect. And you will often get this message on the first try. I'm unsure why, but just click Close and install and select the port again, and usually the second time it connects just fine. So now all we've got to do is install WLED. It's going to prompt us that everything on the current device is going to be overwritten. That's fine, and click Install. So I'm going to speed this part of the video up just a little bit, but just leave this page open, be a little bit patient. It doesn't take very long at all for WLED to install. Okay, so now it's complete. That process really only took about 2 to 2.5 minutes, so it didn't take very long. So we're going to go ahead and click Next, and now it's going to give you the option to actually onboard this onto your Wi-Fi. So you'll want to go ahead and do that here. And now it's going to go out and attempt to connect to your Wi-Fi. So as long as you've got your password and your Wi-Fi entered in, there you go, your device is now connected. And in fact, if you want to actually just try it out right here, you can go ahead and click Visit Device, and it should bring up the WLED interface. Now we're not connected to anything, so we can't try it. Now, do note the IP address of this install of WLED, which you can find up in the browser address bar. You're going to need to know this IP address later to return to the WLED interface. But at this point, we can now disconnect it from your PC, and we're ready to go over and build the controller. Before we start wiring the controller, there are some pins that we need to identify. And the reason why you may need to identify these is not every board has the same pins in the same location, and not every manufacturer labels the pins the same way. So the pins we're going to be using for this particular install is the VN, sometimes labeled 5V, that's our 5-volt pin. We're going to need a ground pin. And then if you are installing the logic level shifter, we're also going to need the 3.3, which is normally labeled 3V3 pin, and a second ground pin. The only other pin we're going to need is the data line that runs to our LEDs. Now, WLED allows you to use a lot of different pins, but the default pin is GPIO2. On this particular board, GPIO2 is the D4 pin. Now, how do I know that? Well, on this particular board, if I look on the back side, it actually has the GPIO numbers on here. And I can see that GPIO2 is my D4 pin. Not every board will have those labeled, so you may need to check online documentation. And there's a pretty good site that will help you identify which pins and line up with which GPIO numbers, and I'll leave a link to that down in the video description. But once we have the pins identified on the board, we're now ready to start the actual assembly. Okay, to start, just place your controller on the breadboard. It really doesn't matter where. Just make sure you know which number here, which column's lining up with which pin. It looks a little bit skewed here in the video, but if I turn this on the side, you'll see that my first pin is actually in column number 3. So just be aware of that. And all we're going to do to start, and I'm just going to use tweezers here really just to try to make it easier to see. On the 5-volt or the VN side, I'm going to connect the VN to the positive rail on one side of the breadboard. So we'll stick that in there. And we're also going to connect the ground on this same side to the negative or the ground rail. Okay, so now I've got my ground connection. That's all the way in there. Now, if you're not using the logic level shifter, we only have one connection left to make. That's the data line. But I am going to go ahead and show you the connections for the logic level shifter if you decide to use one down the road. So to do that, we've got our 5 volts now running along this power rail. We need 3.3 volts for the logic level shifter on the other power rail. And here's my 3V3 pin. And so I'm basically just going to repeat those connections to the power rail on this side. 3V3 to the positive rail. That in there. And then ground to the negative rail. Now, if you're using something like a Wemos D1 Mini, you're going to find out that it only has one ground pin. So what do you do for the second ground connection in that case? Well, it's pretty easy. All you have to do in that case is connect our 2 ground rails together here on the breadboard. Just make sure that if you do that, make sure you are connecting the grounds and not your 3.3 and your 5 volts together. Since we've got a ground on both sides, we don't need that here. So let's take just a little bit closer look here at the logic level shifter. Now notice one side of this is labeled with HVs and the other side is labeled with LVs. The HV is our high voltage side, that's going to be our 5 volts, and the LV is going to be our 3.3 volts. Now there is one HV and one LV pin on each side without any numbers, and a ground. That's where we're going to connect our voltages. So our 5 volts to HV, our 3.3 volts to LV, ground to ground on both sides. Then the ones with the 4 different numbers, 1 through 4, those are the 4 different channels that we can use to actually boost our data signal. So now I've placed the logic level shifter on here, and again, it really doesn't matter. Just make sure you note which column numbers here, which numbers are lining up with which pins. Now, much like the board itself, or our ESP board, I'm simply going to connect on the HV side. Make sure your HV side is on your 5 volt side and your LV is on your 3.3 volt side. I'm just going to connect my HV to my positive on here. And just like the ESP, I'm going to connect ground to the negative. Put that in there. And now I'm going to repeat that same process over here on the 3.3 volt side. So again, I want to go positive to the LV on this side. And once again, ground to the negative on this side. So whether you're using a logic level shifter or not, the last thing we've got to do is the data coming off of this to our LED strip. Now for our data signal, which is on D4, if we're using the logic level shifter, we need to take that signal, run it from the low voltage side, have it be boosted from the 3.3 volts up to 5 volts before we go out to our LED strip. So I'm just going to take and connect here to D4, and it doesn't matter which channel you use here. I'm just going to pick LV4 here at the end. And then what I need to do is I've got my little bit of just stripped solid core wire here, and I can need to connect that to HV4 on the other side. That's the only thing. Whatever channel you're using on the inside needs to be the same channel as on the outside. Now, if you're not using the logic level shifter, you can omit all that and just connect your data out pin here directly to D4 and over to your LED strip. I'm going to go ahead again for now, and I'm going to use the logic level shifter. So we're going to do that. Connect this back to the HV4 side on our high out. and our controller is basically built. Next, we need to make a wire connection for the start of our LED strip. Now there is a start and an end on these. It really doesn't care about voltage, but if you look carefully, you'll see an arrow on your LED strip indicating the direction of the data line travel. So there is an in and an out. You need to make sure you're connecting to the inside with the arrows pointing away from that end of the strip. Normally that's going to have the smaller size female JST connector on it, but it's going to be kind of hard to connect our wires to that. So what we're going to do is we're going to use the male JST connector that has bare wires on the end. Now, as I mentioned, if you don't have or haven't purchased some of these JST connectors, you can go to the end of your strip and you should find, again, a male JST connector there. If you don't have plans on either reusing this strip or daisy chaining them together, all we've got to do is simply take this and we're just going to cut that off, and then we're going to reuse that. And all I need to do is I need to separate these wires apart and then strip them back so we can join them to the wires coming off of our power supply and our controller. Now, one other thing I want to note that I have been asked about, if you look at the beginning of this strip, you'll see our 3 wires that we're going to use. That's going to be our positive, our negative, and our data signal. But I get asked, what are these extra 2 wires for? What should I do with those? Well, those are meant to do power injection when you have especially long LED runs where you may need to inject power along the strip. At the beginning of the strip, we're not going to use those because we're going to be putting our power in through the JST connector. So you can just ignore these extra 2 wires, or you can even cut them off if you like. So I've gone ahead and stripped the wires off of that JST connector. I've gone ahead and cut a couple of short length of solid core wire here, and I've connected that to the positive and negative side of our 5-volt rail. That's what's going to power our controller. And with the power supply, I've just added a couple of wires to this adapter. Again, I don't recommend you use this adapter for any kind of larger installation of LEDs, but for our test install, it's fine. So what we're going to do, first off, is we're going to connect in with our Wago clips here, our power supply. So we'll connect our positive and negative into 2 different clips here. All right, now what we're going to do is we're going to split that power off. We're going to run a line off of the 5 volts directly to the LED strip and another line over here to power our controller. Now the reason we do that is why you might be wondering, why can't I just run 5 volts to this and off of this to the LEDs? Well, for very, very small installations, you can probably get away with that. But this breadboard has pretty small traces in it, and therefore it's not meant to handle high current. So it doesn't take very many LEDs to get up to higher current. I wouldn't run more than maybe 1 or 2 amps. And you may be thinking about, well, I could run this off of USB and run right off of the 5-volt and ground to the LED strip. Well, once again, these boards are not meant to handle that kind of current. There's a very high probability that you're going to end up burning out or destroying your controller by trying to do that. So I always recommend that the right way to do this is to run your power in parallel. Run a 5-volt connection off of your power supply directly to the controller and run another one to your LED strip. So that's what we've got here. I've got 5 volts and ground running to my controller, and I've got 5 volts and ground running to the red and white wires on our strip. So the last thing we've got to do is simply just connect up our 2 grounds. This wire is probably a lot longer than it needs to be, so let me cut this off and make it a little bit shorter. Again, the shorter this wire is, the better, especially if you're not going to use the logic level shifter. So let me just strip a little bit of that off of there. Put this back into that. Okay, now I can connect these up once again using the JST connectors. Now, again, if you're not using the logic level shifter, you're just going to be coming straight off of the D4 or the GPIO2 pin directly into this. And we will connect up the data lines together. Okay, that's it. So that's all we need to do. I want to verify all of my connections. We're going to plug in the power supply. Push over to the other camera and lower the lights a little bit. But let's go ahead and plug in the power supply. And as always, cross our fingers and hope everything works. Now, don't panic if you have more than 30 LEDs and only part of your LEDs light up. I don't know how well you can see that here on the camera, but I do have some down here that aren't lit up. By default, WLED is set up with a pixel count of 30, and they're always going to light up in orange. So The fact that part of your LEDs aren't lit up is fine. We're going to fix that next. Let's go over to WLED, tell the number of pixels we've got, and try out a few effects. Here we are in the WLED interface, and again, I got to that by just going to a browser and putting in the IP address that we identified before for this particular controller. So again, you can see I've got 3 pixels that are unlit because I actually have 33 pixels here, and the default for WLED is 30. So all we've got to do to fix that is we need to go to our configuration, go to our LED preferences, scroll down here until we see this length. Notice how it says 30. Well, in my case, I've got 33. You can just enter in whatever number of pixels that you've got. When I click save, notice my last 3 pixels just lit up. So at that point, we can actually play around with WLED and try some different effects and patterns. We can try different colors over here and really just kind of play around with it. But now you have built your own first controller with WLED and can play around with this thing and see what kind of effects and what kind of options that it has. And there's a lot more things that WLED can do. Besides just all of the different effects and colors, you can create presets and playlists. You can attach push buttons for local control. You can add IR receivers. You can actually, again, add a microphone for sound reactivity if you're using an ESP32. So this just gives you a flavor and is a very quick way that if you want to get your feet wet with creating your own LED controller and playing around with WLED. And so while I do recommend that you consider creating soldered versions of this for anything that's a permanent install, this definitely gives you a chance to test it out. And the good news is that since nothing is soldered together, make sure your power's not connected anymore. It's very easy to simply remove all these parts and you can reuse them in a later project. And remember, you've already got WLED flashed on here, so you can easily create a soldered version out of this down the road. So that's going to do it for this video. Hopefully I've given you confidence to maybe try building your first WLED project if you thought it was a little bit too overwhelming before. Now, if you do me a favor and hit that thumbs up button if you did find something in this video that you liked. If you'd like to see more of my videos, hit that subscribe button and ding that little bell icon if you want to be notified when I release new videos. And after you do build that first controller, you might want to check out this playlist. It's a lot of my other LED projects, including information on how you might add buttons or other controls to your own LED projects. And as always, I'd like to say thank you for watching, and I hope to see you soon.